Find the average rate of change of p of x equals x cubed on the interval from a to a plus h. To do this, we're going to have to look at p of a plus h minus p of a over h. And so specifically, this is going to be a plus h cubed minus a cubed over h. Because our function is the function that cubes the input, and here the input is a plus h, that's going to be a plus h cubed, and then minus a cubed. Now, a plus h cubed is quite a calculation to do, and so what we're going to do is we're going to do this calculation off to the side. So a plus h cubed is going to be a plus h times a plus h times a plus h. And what we're going to do is first we're going to multiply a plus h times a plus h, and once we get the result, we're going to multiply that by a plus h. Now, a plus h times a plus h is something we've done already multiple times just in this lesson. We use the special product formula, and it's a squared plus 2ah plus h squared. You could also FOIL that out if you wanted to. So now we've got a squared plus 2ah plus h squared times a plus h. When we have a trinomial times a binomial, the cleanest and simplest way to multiply this out is with the table method, making a 3 by 2 table. So we've got a squared, 2ah, and h squared as the terms from the first polynomial, and a and h as the terms from the second. Let's go through and multiply to see what the product will be. A times a squared is a cubed. A times 2ah is 2a squared h. And a times h squared is ah squared. Then in the next row, h times a squared is a squared h. I'm going to write the a first in each of these terms, just so we can see what matches up. Then h times 2ah is going to be 2ah squared. And then h times h squared is h cubed. Now, if we want to combine like terms, we can notice that the like terms are the ones that are diagonally across from each other. So we're going to keep the a cubed first, and then a squared h plus 2a squared h gives us 3a squared h. Then 2ah squared plus another ah squared gives us 3ah squared. And lastly, we have that h cubed down in the corner. So once we combine like terms, this is what we get. And this is what we're going to replace a plus h cubed with up here. So this is going to give us a cubed plus 3a squared h plus 3ah squared plus h cubed minus a cubed, and that is all going to be over h. Next, we can do a little bit of canceling. We've got a positive a cubed and a negative a cubed that we can cancel out. And that leaves us with 3 terms in the numerator. And since all of these are being divided by h, we can separate this out into 3a squared h divided by h plus 3ah squared divided by h plus h cubed divided by h. And when we divide all 3 of those terms by h, we get 3a squared plus 3ah plus h squared. And that is our average rate of change. If you take Calculus 1, you will see this exact problem as one piece of an even larger problem. at which point we'll take this and we'll look at what happens when h gets closer and closer to 0. And this is going to give us something called the derivative. It's going to give us the instantaneous rate of change instead of the average rate of change. And it's going to tell us something about the slope of a tangent line to a graph. So this is very important. Unfortunately, though, you will not see the importance until calculus. But when you get there, you'll be much stronger dealing with the algebra.